There you go. Excuse me. One and three, that's just odd numbers. Where's the wow. Hmm. What is going on? Nine, 2, 8, 3, 4, 6, 2. Okay, that should be the right one. Come on. What is going on? Nine six nine 82831. Hey, how you doing?
I'm good.
Yeah, I usually change my Zoom every time. So like, yeah, just try check your email. This usually happens. It's okay.
Yeah.
Okay. So how are you with your studying?
Pretty good. We did like a worksheet the day before
Okay.
yesterday, which was like really hard, but it's nothing like the test apparently.
It's nothing like the test. So
It wasn't anything like the test. So I'm thinking the test will probably she told us what's on the test. It's like there's going to be like 2 or 3 of cosine
okay.
and sine, and then there's going to be 1 of cosecant, 1 secant, 1 tangent, and 1 cotangent.
Okay, I think that's good. I think we already kind of covered most of them, or actually all of them. It's just the domain now, right? And
Yeah.
so have you been practicing like the range and then all the other questions besides like
Yes.
graphing?
Yes.
Okay, so I think you should be good. Just after like what I have right here, maybe we'll cover this first before we do the graph. Did you get this email by the way? I have this, but I don't usually like publish what my notes are. But
Yeah.
I did. Okay. Oh, so you got it. Okay.
Yeah.
That's good. So I guess in terms of domain and range, this will be very helpful if you kind of like in a way like memorize what they are like in their basic function, and because the generality is pretty much the same. Like you're gonna see like for all sines and cosines, and then you can imagine what these are because sines are just this guy and then cosines are just the u's. And then as you can see, the x's, the domains are pretty much the x's, right? And then the range is pretty much the y's, right? So for sine, you can have all real numbers, or this is just another way of like doing this. X equals negative infinity to infinity. That's the same thing.
Yeah.
And then the for cosine is the same thing. X is from negative infinity to infinity, because there's no limit where this wave can end. But if you look at the range being the y, the y for like sine, you know, for a regular sine, it has to be from 1 to -1, right? We've graphed this like many times. It's gonna be from 1 like this, from 1 to -1, right?
Yeah.
So yeah, don't get bogged down by the notation here. This is just saying, like if I were to write this, I would write it like this, like and then for the range, I would probably just write it like from this guy, you know, like the regular way, including -1 to 1, like that.
Yeah.
Same with this one, y from -1 to 1. So yeah, that's for sines and cosines. Those are really easy. The one where you may have to think twice is the cosines, the counterparts, and the secant. And for the domain, thinking about it, like a cosecant is just opposite of a sine, but then they share the like the y's, right? The maximum y's. But the main point here is what is a cosecant? It's just you're gonna have an asymptote where the signs are 0, right? For cosecant. If you remember, so like so a sine graph is A sine graph is this guy, 1,
Yeah,
negative
so it's
1.
just yeah.
And then like your cosecant will have the same thing right here and right here. And then wherever this is 0,
Mm.
you're going to have an asymptote, right?
Yeah.
Yeah. For, and then this one right here, something like that. So where you have an asymptote for your cosecant graph, that's not defined. So you can't have an x there, right? Your domain isn't defined. So like where you have this guy right here, right?
Yeah, I'm listening.
Okay, so wherever you have this guy, where you have an asymptote for your cosecant, you can't have an x there. So wherever, you have this 2 pi, where else do you have sine as a 0? Sine is also 0 at like negative pi.
Yeah.
Sine is also 0 at so on and so forth, right?
Mm.
Does that make sense?
Yeah.
Yeah, so that's for cosecant. Same with the secant.
Okay, so yeah, okay, I get the main.
So that's like the concept of it.
Yeah, it's
Wherever
just
you're,
the asymptotes.
it's just the asymptotes. Then that's what the domain is. Is what can you have? And you can't have what you have to say is you can't have x can't be where the asymptotes are.
Mm-hmm.
Okay, so that's good. For the range or the y's, you already know that one, right?
Yeah.
This is the union one.
Yeah.
Okay. So yeah, these are the only ones that's like kind of iffy for the cosecant secant domains, but it's just you gotta like make it make sense for yourself by saying the x's are not the one. You can't have x's where the asymptotes are.
Mm-hmm.
So sines, cosines, cosecants, secants, those are kind of related. The strange one is the tan and cotangent. And then you already know in essence like how these guys look. Like you're just gonna have this guy kind of like a backwards S for tan, and then like cotangent is like the S looking guy, but then it's like from here to here.
Yeah.
So if you look at this, the y itself goes to infinity and negative infinity. So you can have anything, right, for your range, right? Because you can go up or go down forever, right?
Yeah.
So this is for both the cotangent and tangent. Your range or your y can go from negative infinity to infinity. But the one thing that's different is the domain. And then the domain for these two it's just where you have your asymptotes again. You have to say where you have your asymptotes. So by saying the same way as what we did for cosecant and secant, you have to say x or the domain cannot be for where do you have your asymptotes for your tan?
It's gonna be at the pi over 2's and the negative 3 pi's over 2, the negative 3 pi over 2, and then the pi 3 pi over 2.
Yeah, so counterparts of this guy, pi over 2 and 3 pi over 2, and so on and so forth. And then like for the cotangent one, it's the pi's, right?
Mm-hmm.
Not the fraction one. So these will be like, you have to remember the 0 is in here. This is 0, pi, and then 2 pi, and then counterparts. So that's pretty much it. Like how I would like remember these guys is just really understanding what the graph looks like the basic graph.
Mm-hmm.
And then having this table really summarizes everything. Like, oh, now it makes sense because we've been through like the whole graphing ordeal where you know how to transform it. Though, and knowing what these basic functions are, do know that these will change depending on your transformation. Like these will change, but the concept is still the same. You're still going to be looking for the asymptotes, and we're not there. That's probably the hardest part, looking for the domain where they're not defined. But everything else is kind of straightforward. Okay, does that kind of make sense?
Yeah, that makes sense.
Okay, yeah, just have this table, and I think memorize it today, and then like I think you should be good to go. Okay, let's try to like maybe do a review of like graphing, but the harder ones.
Yeah. Wait, let me.
Because I think especially for these tangent and cotangent and like the counterparts. Okay. Do you have this worksheet?
Yeah, it's in my backpack though. That's in the car, so I think I'm just gonna copy it.
Okay. Let's just maybe. Can you see? I've kind of written on these because I was like doing something earlier just to check if you know what they are. But maybe let's just talk about it.
Mm-hmm.
Okay. So for one right here. So all of these are tan. All of these are tan. So it's just pretty much testing your knowledge of tan.
Mm-hmm.
So for this one, looking at this, what do you think is the right graph? And knowing that tan is always reverse S.
Mm-hmm.
But then when you have like a negative, what happens to that?
It like switches.
So it becomes the kind of like a cotangent, right?
Yeah.
And then okay, and what about this horizontal shift?
It means it's gonna move the asymptotes. So.
And the
It's gonna,
zeros, right? It's gonna move the
yeah.
zeros as well. Okay. So originally it has 0 at 0,
Mm-hmm.
but then I moved it pi over 2 to the left.
Yeah. So it started at pi over 2.
And so you just move it, and then all your zeros should be like shifted. The usual way of me looking at this is the asymptotes and the zeros. But yeah, as long as you know the look of the graph, and then when you have the shift, it just shifts your asymptotes and zeros. Okay, so this is D. What about for this guy? Let's take a look at maybe C.
Mm-hmm.
So there's no negative. That's my first. I always look at if it's a negative or positive amplitude. So there's no negative. It has to be a reverse S. And then when you move it by pi, you're pretty much back to where you are, right?
Yeah.
So it's gonna look exactly the same because it's just a phase change for like a whole period. So yeah, so it's that, like it's pretty much the same. And then for 3, let's take a look at this one. So for 3, this looks like a regular tan, and then it's a shift, right?
Yeah, it got moved to the right.
It got moved to the left.
Yeah, left.
Yeah, because you just have to look at where the asymptotes and zeros are. So it used to have a 0 at pi, but now it has it at pi over 2.
Mm-hmm.
And then what about this one? So this one, it's the S. So it must be a negative tan somehow. So if you look at so this is a negative tan.
Mm-hmm.
And then there's no shift. It could be a pi, but I don't think there's a negative tan with a pi in it. So it's A.
Yeah.
Okay, so that one makes sense for these ones?
Yes.
Okay. Yeah, it's just like, yeah, it was just testing out like the tan and how they look. Let's try looking at these other ones. I think what would help is like let's try graph them and then maybe look at their domains and ranges.
Mm-hmm.
Okay, let me just erase this bunch. Okay, so I guess for what I have here, I'll just trace it. So this is a negative secant. So typically when I have negative secant, I would graph the reciprocal, right? So it's like negative cosine counterpart. So that's what I have here. Like this is a negative cosine. And then like you would just put in an asymptote where it's 0. Put an asymptote where it's 0. And they both share, the secant and cosine, they both share the same like y. So I would just have it there, and then I would have it here. And then it's like that.
Yeah.
And then so let's try see what the domains are, and then the ranges. So the domain and range. Okay. Why don't you tell me what the domains and ranges are?
Would it be
So X and Y.
X like the such or the E or I think use a line. Is it the same thing? X such that X. Well, that's like how we do it in my class. I don't know.
Which one? Oh, you mean you're talking? You're talking about the way you write it.
Yeah, it's like the x
This guy,
in the
right?
line. Yeah, like such like yeah, x is not equal to, and it would be pi over 2 and 3 pi over 2, right?
Yeah, where the asymptotes are. And then like I had a question about because do you guys need to find the domain within the range only, or within like a set X, or do you have to account for everything?
I'm pretty sure it's within a set, like
Like
the
for example, like they want you to graph this between like negative 2 pi to 2 pi, something like that. And then
oh
and then all you have to figure out for X is like where they're within this range, not over the whole entire infinity to infinity.
I don't think we have anything like that on our test.
Okay, so like when you have like the domain, it's just it's only the ones that are within the range, or within the the X range.
Yeah.
Okay, okay, because it's not difficult, like, but if you have to account for like everything, you have to put in like this n value. It would be like 2n plus 1 over like 2, something like that. But we're not gonna do that here. Okay, what about for the range?
It would be 1. Oh wait, you start at negative, don't you? Okay, -1. Oh, negative infinity to -1 union. And then 1 and infinity.
Yeah, 1 and infinity. Yep. Yeah, the range is pretty simple. Okay.
Can we try number 8?
Okay, number 8. Yeah, that one's actually the one I did earlier. Okay, so number 8. So when you have this tan, and then you have an amplitude and also a frequency,
Mm-hmm.
The only thing that changes, the graph doesn't really change much, like in terms of y. It's only like this guy right here is just a multiplier of like the y, right?
Mm-hmm.
Like typically it's like one, like -1 to 1. But then like you times it by 3, so it's -3 to 3, right?
Yeah.
So that's how you account for the amplitude. And then the other thing is, what about the frequency? So you divide for tan, it's not 2 pi, because the period is pi. So it's pi over 2, right? Pi over whatever that number is.
Mm-hmm.
And then this is the period. So it's that period right there spans like the full thing right here, right?
Yeah.
So it's actually, my trick there is I just divide it by 2, so I know where, so it's actually pi over 4, which is this guy.
Yeah.
And then another pi over 4, negative pi over 4. And that's all that changes. And you obviously have to like repeat it. Okay, does that make sense?
Yeah, I get it.
Okay, let's do the domain and range for that one.
Okay. The domain would be like x such that x is not equal to negative pi over 4 and pi over 4.
Anyway, let me actually define the range, of like the x's. Let's make them from -2 pi to 2 pi. So what would be your domain between that? So x such that x is not what?
Okay, wait. How do you do the n pi thingy?
The n pi. Do you guys have to do that?
We might. I don't know.
Okay. So the n pi the ny, how you take account for everything. So for example, what if they tell you every x is from -infinity to infinity, right? Mm-hmm. If you do the domain for that, like that's accounting for everything. So just taking a look at the what you should have is, so you have this like pi over 4, right? Is like the asymptote.
Mm-hmm.
And then you also have 3 pi over 2. And then the other one here is so 3 pi over 2. And I think that's it. And then the other one, +1 plus 1. And then it's like 5 pi over 2. So we see pi over 4 plus pi. Usually add pi to this. Pi over 4. Let me actually do this one. Plus pi. Plus 4 pi over. should be 5 pi over 4. And then the other one would be, so you just add 5 and then, okay, so pi over 4, 5 pi over 4. And then you add, not, like, add 4 again. So, so that's what you have. And usually it messes with, like, just your coefficient right here.
Yeah.
So to account for all of that, you have to write it like this. So not b. And you have to create like a general formula where n has to go from like 0, 1, 2, and so on and so forth, right?
Mm-hmm.
And then so what could be your formula? This one's a more difficult one. Usually it's like 1, 3, and 5, which is like 2n plus 1. But then if you have only 1, 5, and 9, what would you add in there? I think for the one I would do, if you can't find a pattern, I would just lay out like the first few like this. Because sometimes there's no pattern at all. It's like, if you do this, and then pi over 4, 5 pi over 4, and then 9 pi over 4. And then say like, and others, and others. Because there's no pattern. Like, you could, if there was a pattern where it was like pi, and then 3 pi over 2, and 5 pi over 2. You could say that this is like 2n plus 1 pi over 2. And then n can go like this. And you put 0, it's going to be this guy, right? For n. And you put 1, it's going to be this guy. And if you put 2, it's going to be that guy, right? Yeah. If you can't find a pattern, don't try to. Just on your exam, just lay this up. Yeah, just write it down like that, like examples of it, and say others. Because they can, I don't think they expect you to write the general sequence. Okay. Does that kind of make sense? Yeah. I don't think they expect you to write the general sequence if it's complicated, especially when it's transformed. Okay. Does that kind of make sense?
Yeah, that makes sense.
Okay. All right, let's see. Let's start. Okay, do you want to do another one specifically? Let me just erase this one here.
I guess you can do number 9, but that one seems...
Yeah, that one's an easy one, a secant. You want to do that one?
Yeah, sure, we can still do that one.
Okay. Usually the secant and cosecant ones are the more difficult ones, are the easier ones. And then, but then the cotangent, tangent are the harder ones. So for this one, I'll probably do like, the counterpart again. And then like, let's go with, so it's like, the amplitude doesn't change for this one. It's just so it's going to be, let's see. So it's going to be 2 pi divided by 2 to the period is pi. And then so it's like, say pi over 2, pi, 3 pi over 2, 2 pi. So from here to here, and from here to here. And then they share the same thing here. And then you just have to, where it's 0, that's where you have the asymptote. And then you have this guy. Okay. And then you just draw it like this. And then you continue. And then, so that's the graph, right? Okay, the red. So let's try find the domain and ranges for this one.
Okay, wait. So it would just be out of pi. So Our teacher like takes points off if we do more than like,
Oh, really?
yeah.
Okay. If it's usually the way I if they give you like a range, like 0 to 2 pi, yeah, it's this one. Okay. If it's up to pi, just cut it off. Just cut it off right here. Or like right here, actually.
Mm.
Yeah, whatever the range that you need to cut it off. Okay, so from 0 to pi,
Okay, yeah, I see.
what would be the range?
It would be negative infinity, -1, union 1, infinity.
Okay, so for the x's?
It doesn't equal pi over 4, right? Or is that pi over?
Yeah, for this one, it can't be at the asymptotes. I think it's pi over 4. So it can't equal at pi over 4, yeah. Is there another one?
And heck, then you have to ask 5 pi over 4? Was that it?
I think so. It's pi over 4 and then 3 pi over 2?
Oh, yeah, you're right. Never mind.
Yeah, it's between pi over 2. Yeah, 3 pi over 2. Okay, and then the y is everything, right? The thing is, like, if you have a range, you have to be careful. It's not, you can't always default to infinity.
Mm-hmm.
Yeah, remember that, like, if they give you a certain range, you can't just say, like, for example, this one. I mean, for y, if they don't give you a range for y, then it would be infinity. So, like, this guy, if there's no range for y.
Yeah.
If there was, I don't think they usually give you a range for y. It's usually the x's. So y can be like anything. Okay. You want to do another one like that? I think the domain is the one that's usually like hard for most of these. But just remember, it's at the asymptotes.
Yeah.
Okay. Let's see.
Wait, but would I put 3 pi over 2 for the asymptote if it's over the period?
No, you wouldn't. It would just be if it's over, like, depending on your period right here. It's always, you have to always look back at your period. Like, for example, if there's a y range like this guy, or like an x range, you cut it off.
Yeah, wait, isn't it between pi and 3 pi over 2 for the asymptote?
3 pi over 2, but it's over pi, right? Wait, hold up. 3 pi over, let me see what. 3 pi over 2 pi over 4. It's 3 pi over 4. 3 pi over 4. 3 pi over 4. There you go.
Okay.
This is a 2. This is a pi over 4 and 3 pi over 4. Yeah. Okay. Just delete these other guys. Okay, there you go. Okay, so what about these other ones?
We could try number 14.
Okay. Let's take a look at that one. Yeah, usually these are the ones that's like, so for cotangent, it's a regular S, right?
Mm-hmm.
And then that's for a regular if it's not negative. And then if you have this like amplitude, you technically just times since going from infinity to negative infinity, I would just times what you have here, positive, negative. That's your amplitude.
Okay.
It's not like, it's because obviously it's going to infinity. It's up to you where you're gonna put it. And since there's no frequency, it's not gonna change like how wide or whatever it is. But what you have to account for this negative one, which is going to the right, like pi over 4, right? I would just graph it first, the regular one. So for cotangent, what are your zeros usually?
Um,
I always have to look back at this, like, because it's different for the tan.
yeah, it's at 0 and pi, right?
There's no 0. It's cotangent. The zeros are only at pi over 2 and 3 pi over 2
Oh.
for cotangent.
Oh, and tangent's at. I thought that
And
was for tangent. It was at pi over 2 and negative pi over 2.
tangent would be at 0, 0, pi, and 2 pi.
Oh.
Yeah, it's like this. Let me see. This is this guy right here. So this is the regular tan, right?
Oh, yeah, no, I was talking about like the asymptotes.
The asymptotes, yeah. The asymptotes
Oh,
it would be what you
yeah,
just said.
my bad. That's what I was doing.
Okay. The asymptote, like for me, I usually worry about like the zeros, and then yeah, the asymptotes obviously are like the where it's like not there. So let's see, pi over 2, pi, 3 pi over 2, and 2 pi. And then so if you have to move this to the right by pi over 4, let me just draw it out first. It's so this is your 0. This is your 0. So you have that. This is your regular one. And then so now you have to, if you move this to the right by, you just add it, you know, to this pi over 4. It's pi over 4. So it would be 3 pi over 4. I don't like graphing these ones. It's usually like it messes with you. So 3 pi over 2 times 2 times 2, 6 pi over 4 plus pi over 4, so 7 pi over 4. 7 pi over 4. And your asymptotes is going to be at pi over 4. This is, let's say 4 pi over 4 plus pi over 4. That's 5 pi over 4. 5 pi over 4. That's your asymptotes. All right, like that. And then 8 pi over 4, 9 pi over 4. 9 pi over 4. She really takes out points if you don't draw it at the right
Yeah,
range.
if you do for like more than 1 pi.
Because like if it's transformed like this, it's like the last thing you want to do.
Yeah, it's like the only thing we can do. If we do it over, then she takes off points.
I would probably just draw it, check yourself. Okay, is this within the range? Just erase like up to this point, you know. Because yeah, like I'd rather have like a free will. Yeah, I'd rather be drawing it like not limited to what I can do, and then just edit. Okay, so that's what that is. Oh yeah, forgot the y. The y is at 1/2 and then negative 1/2. Okay, so what's your domains and ranges?
Okay, so the domain wouldn't be pi over 4 and 5 pi over 4?
Yeah, pi over 4, 5 pi over 4. For the if this is all the way from 0 to pi, yeah. Or 2 pi rather.
Oh, okay, then it'd be
if it's just yeah, not 9 pi over 4 is over 2 pi.
Oh, it is?
Yeah, because you have 8 here over 4, that's 2 pi, right?
Oh, yeah, you're right.
Yeah, you have to check yourself with that one, yeah. Like it's a bunch of small checks, but it will get like it's more natural. It's gonna get more natural if you do it more. But then if you don't practice, it's gonna be difficult because then for example, like checking it, if your graph is within range, is your domain within range? And I think for range itself, it doesn't really matter. So for this one,
yeah, negative infinity.
Yeah, as long as you know what you have to check for, because like like not only that you guys are timed, but then you may forget something because you're super stressed.
Yes.
Yeah, but that stress will go down the more practice you do. But like at least you know what you're aware of and what to check. that's the part that matters. Because if we didn't go over this, you wouldn't know. So
Mm-hmm.
okay. So that's it for that. What about these other ones?
We could do maybe 13.
13. Okay.
But we just did a shift of 1/4. Maybe
Okay. Yeah, we did.
maybe 16.
All right. The vertical shifts. Okay. All right. So I would first of all again draw out the regular counterpart. -1. Okay. So 1, -1. There's no change there. Pi over 2, pi, 3 pi over 2, 2 pi. And then so this is shift to the left by pi over 2. This is shift down by -1. So shift to the left by pi over 2. So the first one is from here. So it would be, let me just draw out the first one. Okay, so then if you're going to move it, minus pi over 2, minus pi over 2. And this is at pi over 2. Three pi over 2, or pi. Okay, so that, and then the next one would be moving the vertical. Which is minusing 1 from this guy, minusing 1. You start off at 0, -2. Okay. All right, did you graph this one?
Yeah.
Okay. So that's pretty much shifting it to the bottom and then to the left. What would be the range of this guy and a domain? And then hold up. Let me see. I forgot to do that. So
So the range would be -infinity to -2, right? And then
let me look at this guy first. The range would be Yeah, negative infinity to this guy right here. What was it 0 and negative 2, I believe, right? Negative 2, yeah. Yes.
And then yeah, infinity 0 to infinity.
Yep. And then what about your x?
It would not be equal to negative pi over 2 and pi over 2.
So this one.
Or wait, no, 3 pi over 2.
So what was it? What was the first one?
Negative pi over 2.
And then
3 pi over 2.
3 pi over 2. Let me just check first. Let me see. And -1, okay. Negative pi over 2. Well, the range is correct.
What's wrong with the domain?
The domain has to be here. Let me actually graph how it looks like. So let's say it has to be this pi, 2 pi, negative pi.
Oh yeah, because wait, it's out of
Yeah.
Okay, so
And
then
then
yeah.
and then that negative 2, wherever that negative 2 is, negative 2. Can't pass that one. And then you have this guy. Yep. And then the other one is from here to here, something like that.
Mm-hmm.
So the asymptotes are at 0, pi. So it will be negative pi, 0, pi, 2 pi.
Regularly, right? But it's
Minus,
moved.
but yeah, you moved it down, right? So it's 0. This is 0 plus pi over 2. Is it pi plus pi over 2? How did you graph it? Like, did your graph look like this? Or was it moved to the left? Because I know it's 0. Let me see if you did this correctly.
My graph looks like, wait.
So let me see. So it's there.
I can like show you. My graph looks like, heck, like this.
Where's your asymptotes, first of all?
It's at negative pi over 2 and pi over 2 because it switched, because it moved over.
Negative pi over 2 and pi over 2, or 3 pi over 2?
I mean 3 pi over 2.
Okay. One. Let me confirm that one. Wolf. Still getting that one. So, why is that? So if your graph for this, let me see. So this is pi over 2. Okay. Oops. That's weird. So like I think it might be right, but then usually the graph that I'm getting, because I have this graphing calculator online, it's not giving you the right one, which doesn't make sense.
Oh.
Yeah. So what I would say is since that's the graph, let's just delete these guys. So since you have asymptotes right there and there, and you share that one. You also share this, so that guy goes like that. Doesn't make sense. Let me see. Why is it? We'll just go with that. Okay. So wherever the 0 is, just have that as like the domain. So it has to be negative pi over 2 and 3 pi over 2, where the asymptotes are.
Mm-hmm.
That one's a little weird. Like when you do a vertical shift.
Yeah.
When you do a vertical shift for like when it's like not an actual cosine or sine, it's a little weird. But I think that will be probably like one of the harder ones, if anything. Okay. Let's just review. So that's the last one. Let's review the one I have, which is this. And let's just talk about domains and ranges. Okay, so these are the graphs. And there's not that much. I think it'll be easy. Why don't you tell me the domains and ranges? Are you still there?
Yeah, I'm there.
Okay, let's just top this off so that we can like review the domains and ranges.
Mm-hmm.
Okay, let's go with 1 and then like wherever we finish. So for 1, what is the domain and range?
So the oh no.
It's not that bad.
Gosh. It looks bad. Okay.
The other one's not this one.
Yeah. So it's not equal to, it wouldn't be equal to pi over 6, right?
Yeah.
At least.
So,
So I know that.
so it's just this guy. It's just this guy, yeah. And then for this guy, yeah, this is gonna be what? Yeah.
Oh wait, you're right. Okay.
Which one are you talking? I don't even know what.
Okay, never mind. Okay, we're doing it. Never mind.
We
Okay.
we work
Okay,
on like the
okay.
opposite
Okay.
so much that like sometimes you have to go back to like the basics.
Okay, yeah. You're right. You're right. Okay, and then the range would be -3 and 3, right?
Yeah. Yep. Okay, so for this one right here.
Mm-hmm. Domain is -infinity to infinity, and the range is -3 and 3.
Yeah. So there, this isn't bad. So 3 and 3, and then this one.
The domain would be -infinity to infinity, and the range would be 0 to 4.
0 to 4. And then this one.
Domain is the same, and the range would be -3 to -1.
-3, -1. All right. So now these guys. So 5. What's the
Okay.
domain?
The domain.
So y is usually the easy one.
Yeah, it's infinity or negative infinity to infinity. The domain would be because it got shifted. What?
So looking back at like what we just did at that table right here. This is for Tanya.
Mm-hmm.
So all you have to ask is what are the asymptotes?
Would it
So
be
just wherever these guys are. So yeah, you just have to look at the asymptotes.
mm,
I guess I could delete it because they're blocking the number. Okay, so maybe from this graph, whichever one they are. Like you don't have to tell me everything, but which ones are they in this graph?
for number 5?
Yeah,
Pi
x
over.
can't x can't be.
Oh yeah, x can't be negative pi over 4 and pi over
Okay,
3 pi over 4, 5 pi over 4, 7 pi over 4.
okay, good. That's not that bad. So for this one, 6.
Would it be pi over 2 and 7 pi over 2?
Pi over 2, 7 pi over 2. Yeah, for the ones that are shown. If you have the graph, it's super easy. But then, like, when you have to think about drawing it and having the right one,
Yeah.
and then trying to figure that out is especially for exam setting. Okay, so 7 and 8.
Okay, would not,
So this one.
uh, is it pi, is that, so pi over 2? No, wait,
So what is the domain first? That's the asymptotes, right?
um, yeah,
Asymptotes. I
I'm
think pi
looking,
over 2.
yeah, pi
I
over
think I
2.
think this is pi over 2. Yeah, and then this is 2
3,
pi plus like pi over 2. So 5 pi over 2,
mm-hmm.
something like that. So it can't be like pi over 2, 5 pi over 2, so on and so forth. And then y, this is the one with the union.
Is that, negative point 0.5, negative infinity to negative point 0.5, and then point 0.5 to infinity?
Yep. Yeah, that's it's not that bad. Just like it'd be nice. Like when I'm asking these things, because like then we're going through all of them. Are you still like, is it natural or is it still unnatural? Trying to go convince yourself from tan to like secant.
Oh, no, it's not really that hard.
Okay, good. Because it should be like knowing that table and how to partition them. I was like, okay, is it a union or is it like an infinity? Just
Yeah.
like yeah, just make sure like yeah, like because sometimes you may when you're really like speeding yourself up, you may confuse them. But I think it's not that bad.
Mm-hmm.
Okay,
Is this at pi over 2 again?
I think so. And then this one,
Is the
I think
5
it's kind of similar.
over 2? Yeah. And then the range is negative infinity to negative 3 and 3 to infinity.
3, 3. Yeah. So it's yep. And then okay, so that's it for that. I don't know if you guys have other problems for these guys, but what if you had to look at this and then tell me what you have to do to transform it
Um,
from like cosine, like from the basic graph? So what would you do first?
it would
Not
be
not
amplitude.
looking at this.
So the amplitude would be 5. So it would be stretched by 5.
Okay.
It would horizontally shift to the right by 5 pi over 6.
To the right or to the left?
To the, oh, to the left.
Okay. So left. 5 pi over 6. Okay, that's good. Okay. And then this one. Not looking at this. Okay. So what would be the first thing?
So you would move over the 5, so it's just like easier for you to see. So normally, like with my teacher, you would take out the 8, so you would divide 3 pi.
This one, right? Oh, yeah, you could do that, like this guy,
Mm-hmm.
and whatever factor it out, whatever it is.
Yeah,
I
so
think you just divide it
left by whatever it was divided by, whatever.
like that.
Yeah,
Yeah.
yeah.
Okay.
And it would shift up by 5.
And ship also up 5. I usually do the frequency first, so that's 1/8.
Yeah, yeah.
And then this one is to the left, 3 pi over 4 times 8. And this is like a shrink, something like that. Okay, what about this one?
So you would move it to the right by pi over 6, and then you would vertically shift down by 2.
And then down by 2. Okay, that's good. And then this one?
So it would be amplitude. The amplitude would be 1 over 10, and then you would move right by pi over 3.
And right by pi over 3. Cool. Yeah, it's not that bad. If you go through like the process of these guys, I think we didn't really cover the y-intercept and then also the x's when they're 0.
Mm-hmm.
But if you put that together, I think you should be good. Like you have like what, today and tomorrow, right?
Yeah.
How do you feel now, like after we went over the domain?
I think I'm pretty solid about it.
Okay, that's like that's pretty good. Okay, hopefully, yeah, like just practice the domain. You said you had like a worksheet, right?
Yeah.
And that one like, because like what I'm thinking is if it's too hard, maybe and did the teacher say that it's not gonna be on the test?
It's not gonna be on the test. Yeah,
Yeah,
like
because
whatever. But I have an extra. I'm pretty sure I have extra worksheets that I could work on too.
okay, yeah, just
Maybe.
as much as you can, like do like from where we started with like the sines,
Yeah.
and then all the way to cotangent, and then like domains. I think that was it, right? There was like no other difficult one. Yeah, the y-intercepts. Make sure, because now that you covered like all the concepts, make sure like you do like them with accuracy and speed for the exam, and then like all the nitty gritty like small things that you have to remember.
Mm-hmm.
Make sure like when you're checking it, check the range of how you're graphing it,
Yeah.
and then also especially the domain. Check the domain if you're within range.
Mm-hmm.
And then your vertical asymptotes. Yeah. Cool. I think you're set, and then let me know if you do great on Friday.
I will.
Okay, I'm sure you will. Cool. And then for the next one, can you send me like the rest of what you guys get next week?
Yeah.
And then like I'll let you know, I guess when, because I don't know if you guys will get it right after the test. Usually you guys don't. Cool. All right. Have a good one. See you next time.
Thank you.